Dear students, today we'll see what do we mean by multiplexing. So multiplexing basically is a process where we say many into one. That means here in a communication it will be many signals onto a one composite signal. So many signals we are going to combine on one composite signal and send it on a shared medium to the receiver part. So as I have shown in this diagram, simple one, where we have shown a multiplexer, and for that multiplexer I have given many inputs 1, 2, 3, 4 dot 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 till n. Those inputs are nothing but different signals. Different signals are going to get combined into multiplexer. Multiplexer is a circuit which will combine many into one. So it will combine them on a composite signal. It will become one composite signal. That composite signal from this transmitter section through a medium will be given to the receiver section, where it should be first demultiplexed, and then all those signals which were combined here should be separated there, and the separate signals should go to their respective destinations. This is the basic idea of what is multiplexing. So basically multiplexing will be many into one. Many signals we are going to combine as one composite signal and put it on a shared medium so that it can transmit from transmitter to receiver, and while receiving it we are going to demultiplex it and separate the signals and give to their respective destinations. After this we will go to see what are types of multiplexing. Okay, now students, we will see types of multiplexing. So basically there are two types of multiplexing. Those are called as analog multiplexing and digital multiplexing. So analog multiplexing is one where signals which are going to combine many into one are analog, and a digital multiplexing is one where signals which are going to combine many into one are in digital format. So here I have shown multiplexer is basically divided into two types. One is analog and one is a digital. In analog, you are having further two types. The first one is called as frequency division multiplexing, and the second one is called as wavelength division multiplexing. In frequency or division multiplexing, that is FDM, the signals are combined together and made a composite signal based on frequencies. Similarly, a WDM, wavelength or division multiplexing, the signals are combined together based on wavelength, and it is mostly used in light spectrum. Similarly, if you see a digital is having one type of multiplexing which is called as time division multiplexing, where signals are combined many into one on the basis of time. And further, they are also again divided as synchronous or TDM and asynchronous TDM. In synchronous or time division multiplexing, the signaling rate of every signal will be same. So it is called as synchronous. And in asynchronous, the signaling rate of every signal which you are going to combine as one will be different. That's why they are called as synchronous and asynchronous. So this is the basic or division or types of multiplexing. Analog, digital, basic form. Analog again in FDM or WDM, or digital goes with a TDM, and again TDM is separated as synchronous or TDM and asynchronous TDM. Dear students, now we will see what do we mean by frequency division multiplexing. But before going to frequency division multiplexing, we should know the concept of what was modulation we studied earlier. So in modulation we studied that the most important advantage of that was multiplexing. So here, what is modulation? Modulation will be whenever a parameter of a carrier like amplitude, frequency or phase is going to change according to the instantaneous value of modulating signal, that was called as modulation. Say for example, if you are having amplitude modulation, and in that if you are having a signal which is say 1 kilohertz, and if you're having carrier as 100 kilohertz, then it will have a bandwidth 100 minus 1 to 100 plus 1 in case of amplitude modulation. That means it will have a bandwidth from 99 kilohertz to 101 kilohertz. So here the signal was 1 kilohertz, carrier was 100 kilohertz, and the bandwidth what is required will be from 99 kilohertz to 101 kilohertz. So we have shifted the frequency spectrum of signal from 0 to 1 kilohertz to 99 kilohertz to 10 kilohertz. This is what we have studied in modulation. So modulators are important here to understand first when we see what is frequency division multiplexing. Dear students, now we will see what do we mean by frequency division multiplexing. So here the basic concept is we are going to combine many signals into one on the basis of frequency. But only provided thing is that whenever we are going to combine them as one composite signal, the channel which is going to carry that composite signal, its capacity, its frequency handling capacity, how much frequency bandwidth it can handle, that should be more than the combined bandwidth of all these signals. Then only that can be properly transmitted. So here in this diagram, we have shown the basic multiplexing part, what happens in the transmitter of a frequency division multiplexing. So initially we have taken only 3 signals for simplicity. Now first signal, second signal and third signal. These are your information wave in electrical form. These are low signals, low frequency signals. They can be audio signals or video signals which are converted into electrical signals, but they are low frequency signals. So they are your base band signals. They start from 0 and end to something. Okay. So those should be first passed through low pass filters so that a correct frequency, a correct range of frequency of that particular application is passed. So low pass filters are the first section. After that, this signal, which was a low frequency signal, will modulate a carrier in these modulators. So this signal will modulate a carrier of this modulator. This signal will modulate a carrier of this modulator, and the last signal will modulate a carrier of this modulator. So all these carriers are of different values. They are not of same values. So that different frequency ranges are allocated. So these signals will modulate the carriers here, and those modulated carrier will go to a pass band now because the frequency spectrum will change, and those should be passed through band pass filters properly with proper cutoff frequencies. Then once they are passed, the first carrier, the second carrier and third carrier, all these carriers which are at different frequency bandwidth, they are multiplexed by the multiplexer, and they are combined as one composite signal with a guard band between them so that they don't get mixed up, they don't get interfered. With a guard band between them, they are combined as one composite signal and then are transmitted from here to the receiver on a shared channel or any transmission medium which can handle the capacity of that bandwidth. Now, in the demultiplexing part, that is in the receiver part of frequency division multiplexing, that is when the composite signal from the transmitter has reached the receiver, first it will meet the demultiplexer. So this demultiplexer will separate those signals and they will be passed through the respective bandpass filters, which will have their cutoff frequencies based on what they have to pass, that particular signal channel should pass. So the first one will go here for its first bandpass filter, second will go to the second bandpass filter, and third will go to the third bandpass filter. So these bandpass filters will pass those proper pass bands through these bandpass filters. So then those modulated carrier which fall in that frequency ranges will be demodulated. That means the information in those modulated carrier will be extracted, demodulation will be done, and that low frequency information will be taken. Now those information will pass through proper cutoff frequency low pass filters to get the proper signal back, and then those signals are given to their respective locations for their particular applications. This will be the demultiplexing part which takes place in the receiver of a frequency division multiplexing technique. So if you join the transmitter and receiver section, you will understand the complete frequency division multiplexing technique, where the signals are multiplexed on the basis of frequency, and between every frequency range there is a guard band left so that they don't interfere with each other. Okay, this is your frequency division multiplexing. Lastly, students, I would like to say about applications of FDM, and in that initially FDM was used for telephones. So there all the voice signals were made multiplexed into one. But nowadays you can see it in a radio broadcast also, and also TV broadcast, where so many channels come to your house place, house location through a simple cable, and so many channels you can tune to, and you can see this is all happening because of frequency division multiplexing.